Okay, question number 3 is to do with simultaneous equations, setting up simultaneous equations and solving them. So in this particular case, we're given a formula, s equals ut plus a half at squared, and some information. Form two simultaneous equations to find the acceleration and u. So we're after u and a in this formula. There's two things we don't know, so we need two scenarios, if you like, to be able to identify what they are. So we need the first situation, which is telling me that after 5 seconds, this object, whatever it is that's travelling along, has gone 120 metres. And after 12 seconds, it's gone 514.8 metres. So I can substitute these values into this equation to form two equations. So the first one will be 120, because the s is the distance, is u, which we don't know, times by the time, which is 5 seconds, plus a half times a times t squared, which is 5 squared. So we can do a similar thing for the second equation. 514.8 equals u times 12 plus a half a times 12 squared. And then we can tidy up. We can say, for equation number 1, 120 equals, well, we used to put in the number first, so I'd write it as 5u plus 25. 5 squared is 25, a half of 25 is 12 and a half, 12.5a. We can do a similar thing for the second one. 514.8 equals 12u plus 12 squared is 144, half of 144 is 72a. So now we have two equations. Let's call them 1 and 2. Two equations, two unknowns, u and a. And so, in theory, we can find them. And the way that there's two ways to do it, and probably the easiest way is the elimination method, which is where we try and get u or a the same in both equations, and then we can eliminate it. Well, probably the easiest one is u. So we can multiply u by 12 to make 144u, and equation 2 by 5. So if I multiply this by 12, I get 144u. If I multiply this by 5, I get 144u. So we can multiply by 5. Sorry, multiply equation 1 by 12 and multiply equation 2 by 5. And then we'd have u's the same, and then we can subtract one equation from the other to try and find out what a is. Carry on and see if you can do that. Another way we can do this, actually we could get u to be just 1u by dividing by 5. We could get this to be 1u by dividing by 12. So another way to do this would be or divide by 5 and multiply by 12. That too will work. Sorry, not multiply by 12, divide by 12. That too will work. You could try both methods and see if you could get the answer out. I'm going to try the second one for my solution. So what I'm going to do is divide equation number 1 by 5 and equation number 2 by 12 and end up with two more equations. Okay, so now I have two more equations, call them 3 and 4, where I've divided number 1 by 12 and number 2 by 5. You can see actually this is probably a more straightforward one to play with than if I'd multiplied by 12 and multiplied by 5. But the answer will come out to be the same. So now I have a situation where u's are the same in both. So if I subtract one equation from the other, u's will disappear, which is what I want to happen. The only question is which way round. Well, if I take 2.5a away from 6a, I'll end up with a positive number, which is probably a good idea. So I'm going to do equation 4, take away equation 3. and I'll end up with 42.9 take away 24 equals a certain number of A. So that gives me that 18.9 equals 3.5A. So now I can calculate A, substitute my value for A back into one of the original equations, say number 1, to find U. And once I've done that, I'll then use my values of U and A in the second equation to check it works and gives me 514.8. And I suggest you do that if you have time in the exam, because then you'll know you've got it right. So see if you can carry on and finish it off. I'll put the solution underneath. So I get that A equals 5.4. Substitute this value for A in equation number 1, which gives me that 120 equals 5U plus 12.5 times A, which is 5.4. Working that out, I get U equals 10.5. And then putting my values for U and A back into the original formula, work out what that is. I get 514.8, which is what it should be. So I know I've got it right.